In part B, we're asked to find the smallest force applied at point B, it's down here, that creates a 576 Newton meter clockwise moment about point C. And because that moment is generically equal to force times some perpendicular distance, then if we're going to make that small as possible, we got to make the perpendicular distance the largest possible. And that's going to be then that we have this 75 millimeter distance between B and C. Any other orientation of the force other than horizontal is going to make that distance smaller, and therefore will make F even larger. Right, and that's why you'll see the work down here that we're going to take clockwise as positive, and so we get F sub B times this moment arm 0.075 meters, set it equal to 576 Newton meters, and get then a total force magnitude of 7,680 newtons acting to the left, or 7.68 kilonewtons again acting to the left. If you interpreted this problem statement slightly differently and kept the 300 Newton force in here, it's going to be passing in a clockwise fashion about point C. That will, of course, make your final answer, F sub B, a little bit smaller. You get a little bit more work that you have to deal with. You could break AX and AY down into, or the 300 Newton force into its X components and Y components, and that makes the math really easy to do, but you got a little bit more you have to do. If you go so far as to say, now I'm going to also include the effects of the pin reactions at D, that means you're going to have to make an assumption about the scenario about equilibrium, and it also makes it much more difficult. The simplest thing that was being asked was really just this very simple case of what force at B would cause about C this clockwise moment of 576 Newton meters.